Good morning. So next one is your unit 5. That is the continuation of fourth unit. So in fourth unit we are seeing about architecture, addressing mode, everything. So here we are going to interface your microcontroller with some external devices similar to that of third unit in 8086. The first topic will be programming 8051 timers and counters. So you are going to program timers and counters with the help of 8051. So it will generally, this programming will take two process. So first one is your mode 1 operation, second one is your mode 2 operation. So you are going to feed the programs into a microcontroller in order to operate that 8051 as a timer and counter. So different programs for each timer and counter. Next, so if it is operated in mode 1 means, so it has a two registers TH and TL. So these registers will go high whenever this memory goes to FFF till reaches a maximum memory. It goes to a high state, and this will be indicated with the help of this overflow float. As I said earlier, whenever the memory will be exceeded, this overflow will be indicated as set to 1 in order to show this. If so, this it exits the maximum memory location. Next one is your the steps involved in programming mode 1. So in mode 1, so it accesses maximum value of 0002 FF to be loaded into the timer registers TL and TH. Once the TH and TL registers are loaded with the values, each 8-bit to a particular register. For example, TL will hold a particular 8-bit and TH will hold a particular 8-bit. So together it is a 16-bit values. This 16-bit will be loaded into TH and TL. Once it is loaded means the timer will be started. So this is done with the help of this command setb tr0. If a timer 0 is used means they can indicate a tr0. Setb tr1. This command is used to set the timer 1. Next one is your mode 2 programming. In mode 2 programming, it allows a maximum value of 000 to FF. So there in mode 1, it takes a 4 zeros to 4F that can be loaded into TL and TH registers. Here, these values can be loaded into the timer registers TH alone. As I said earlier, TH will hold a 8-bit and TL will hold a 8-bit. So here only TH register will be used. Since the TH register will be used means you can load a 8-bit value and the 8051 will give the copy of this TH content to its TL. So then the timer must be started for its operation. This can be done by the command setb tr0 in case of timer 1 and setb tr1 for timer 2. Once the timer is started, it starts to count from its initial value 000 to maximum value of FF. Till it reaches a value of FF, it starts to count from 1 by 1 from 00 to FF. If it exceeds the maximum value of FF, the timer flag will be set with the help of the overflow flag. The overflow flag indicates that it exceeds the maximum value of FF. So when the TL register rolls from FF to 00 and this timer flag will be set to 1 and this timer flag set to 1 means the overflow flag will indicate it started to overflow its memory. So next TL is reloaded automatically with the same value as that of TH register. So for example, if TH register will hold a value of 101140 10101010. So totally 8 bits. That 8 bits can be transferred to the TL registers automatically in order to repeat the process continuously. So this is the overall diagram in order to show the TH register operation. The TL register will be automatically reloaded with the data present in the TH registers. The oscillator frequency will be generated in order to do generate a clock pulses. With the help of these clock pulses, edge triggered clock pulses, the timer will start to initiate. The overflow flag indicates when the memory exceeds the value of FF. So FF is why they are using for FF means in mode 2. So the data value varies from 00 to FF. In mode 1, the data value varies from 4 zeros to FF. So mode 0 and mode 1, there will be two modes of operation. Next one is your counter programming. So that a counter programming is nothing but when C bar T will be equal to 1 means the timer is used to count the value and gets its pulses from the 8051 processor. If the counter counts up to the maximum pulses, it feeds from the T0 and T1. These two pins T0 and T1 will be belong to port 3, and this pin will provides the pin port 3, fourth pin will provide the clock pulse in order to count the each clock pulses which is coming as an input to the counter. Similarly, if timer, if it operates as a timer means the C bar T is equal to 1 for each clock pulses coming from the pin 3.5. 3.5 is nothing but port 3 fifth pin, and it acts as the counter to count up. If port 3 fourth pin will be act as a T0, the timer counter 0 will be acted. If port 3 fifth pin will be act as a T1 means the timer counter 1 will be acts as an external input. The counter programming will be similar to that of timer programming. Next, serial port programming. As I said in processor unit, serial communication will transfer a single bit at a time. So here some of the registers in order to control this serial port programming, that is a T mode registers and T-con registers. So if it is acted as a counter means, so T-con registers will be used to control the counter programming, and T mode registers will be used to control the timer programming. So various programming concepts will be used in order to perform this interfacing operations. Similarly, interrupt programming will be performed in two modes as an internal timer interrupt and external hardware interrupt. So various interfacing can be performed with the help of this 8051 microcontroller.